Determine the deflection at the free end and the max deflection using DIM. Use Macaulay functions to construct the moment function. So ito po yung problem natin today. We have a simply supported overhang beam that has a triangular loading and a constant distributed loading. So you can also see here a location or orientation rather ng positive deflection. So V for deflection for this problem. Maybe using Y, pero okay lang yun. So V yung gagamitin natin. Tapos yung sense ng positive X, which is to the right. Tapos it also indicates the location of the origin of our coordinate axis, which is on the left end. So that is at x equals 0, nandoon yung free end. So before we proceed, let's just review yung Macaulay functions. So this is a table from Mechanics of Materials by Hibbeler 8th edition. So what you can see here is yung headers, you have loading function, shear, and moment. Sa ating problem, ang gagamitin natin is yung sa moment. So ano bang binibigay ng table na to? Binibigay niya yung moment function for a certain type of loading. For example, sa row 1, meron kang clockwise na applied moment. So this is external load. Tapos ito yung moment function ng internal load. You have positive m sub 0 x minus a raised to 0. And you can also see an x and an a. So ano ba yung x na yan? That is the positive. Ayan yung x coordinates given an origin. So yung origin nito is nasa left end. Tapos yung orientation ng x is to the right, positive. Yung a na yan is kung saan nagsisimula yung or saan applied yung loading natin. For this case, the moment is applied at x is equal to a, kaya meron akong x minus a dito. So that's for the moment. This is for the applied load. And this is for the distributed loading. And this is for the slope. So just to emphasize some things, all moment functions in this table are positive, and you need to adjust the values accordingly for negative loadings. So for clockwise moment, positive m, for upwards p, positive m, for upwards omega, positive m, and for upwards or a positive slope triangular loading, you have a positive m. So that's the first one. The second thing that I want to tell you or to emphasize is yung origin nito, as I said before, is nasa left end and that positive x to the right. This is very important kasi makikita nyo mamaya kung bakit. For 3 and 4, yung beam natin should be loaded all the way up to the end, all the way up to the positive end for the expressions to be valid. And then lastly, sir, ano ba ibig sabihin, no? Angular brackets. Ibig sabihin na angle brackets, kapag yung nasa loob is not positive or kapag negative or 0, then 0 na yung term natin. Yan. Okay? Sige, pwede tayo magsimula. Pero bago yun, let me just show you the support reaction. So this is for this roller and this is for the triangular loading. Before we proceed, kailangan natin mag-draw ng approximate elastic curve or deflection curve. That curve shows you how the beam deflects given the loading, no? So, bakit kailangan mag-draw nun? Kasi magiging useful siya mamaya sa pag-locate ng ating max deflection sa pag-evaluate ng sense ng ating mga sagot. So, normally, ginagamit natin V is equal to 0 yung beam axis natin. Okay? Tapos, may dalawa lang kayong guides para makapag-approximate ng beam deflection. No? Titingnan nyo yung supports. Yan. Saan walang displacement and saan walang slope. Yan yung mga dalawang tanong na kailangan nyo sagutin. So for example, sa problem natin, ang concern natin yung una, no? Saan walang displacement? Tandaan nyo that supports that resist a force restrict displacement. Ibig sabihin, yung support na nagbibigay ng force reaction, wala dong displacement. Okay, kaya nga siya support. So, sa location ng roller and ng triangular load, dapat mag-intersect yung ating deflection curve doon sa V is equal to 0 line. So, yan. Okay, next, doon naman sa saan walang slope. Kasi yung supports na nagre-resist ng moment, nagre-restrict siya ng rotation. So sa case natin, wala naman tayong fixed support dito, no? So hindi to magiging concern sa atin. Okay, Now we can approximate the elastic curve in between the supports. Let's just say this is what the deflected shape will look like. And then doon sa pre-end, let's just say ito yun. Okay, so again, approximate lang. Mamaya verify natin yan. Or even, we will revise it as we solve values. Now, pwede na tayong gumamit ng table to derive the moment function. So we want the moment function because we know that's equal to EI times V double prime. Or conversely, yung theory is M over EI is equal to V double prime. Tapos, we integrate twice to get V. Kaya siya double integration method. Okay? So, pwede na nating computein yung or determine yung M. So, ang case natin is dalawang distributed loading. Isang triangular load, isang constant distributed load. Tandaan nyo yung sinabi ko kanina, kailangan lahat ng loading na to, loaded siya or continuous siya hanggang doon sa positive end. For the constant distributed load, wala tayong concern kasi loaded siya hanggang positive end. So, dito siya nag-start, tapos dito siya nag-end. Ang problem natin is yung triangular loading. Hindi siya loaded hanggang sa positive end. So, paano yan? So, ganito siya ginagawa, no? So, what you do is you can extend the triangular loading all the way up to the positive end. Kasi yun yung gusto natin, di ba? Tapos, imagine, I draw a horizontal line. Okay? So, makikita nyo, yung portion na to, okay, yung hina-highlight ko na portion, equal na yan doon sa ating original loading. Okay? So, ibig sabihin, kapag ni-negate ko yung triangular loading na to by drawing this triangular loading, mapupunta na ako doon sa, or makukuha ko na yung original distributed loading. Okay? Tapos, you will notice that the loading at the above the beam is loaded all the way up to the positive end. The loading at the bottom of the beam is loaded all the way up to the positive end. Ibig sabihin, pwede nating magamit yung item 4 doon sa table natin. Okay? So, ganun lang po siya ginagawa. No? I-extend mo muna, in general, i-extend mo hanggang positive end, tapos i-negates mo yung susobra. Ganun siya ginagawa. Okay? Silagay lang natin yung reactions. Now, pwede na natin magamit yung table. Unahin natin yung nasa taas na loading. So, ito yung gagamitin natin. So, what we need is the slope, M, tas divide by 6, tas X minus the start of the application, the load, Q. So, ano yung slope? So, yung slope niyan, pwede ko ma-compute dito sa slope ng triangle na to. Okay, kasi in-extend lang naman natin, no? So, kung ano man yung slope nito, yun din yung magiging slope ng malaking triangle. So, we know that this height is 6. This distance is 9. So, yung slope is just simply 6 over 9. Okay? Rise over run. Kamat. So, 6 over 9 divided by 6, x minus, yung A is 0. Bakit? Kasi ito yung origin. Nagsimula yung triangular loading natin. So, this is the origin. Nagsimula yung triangular loading natin. At x is equal to 0. Kaya, yung A natin is 0. Now, may na-notice pa kayo, negative dapat kasi yung arrow, okay, downwards. Whereas yung arrow doon sa table is upwards. Yun, yung sinabi ko kanina, positive to lahat, no? Yung sa problem natin, should be negative kasi downward siya. Now, next is yung green na triangular loading. Saan siya nagsimula? X is equal to 9. Okay, so dito siya nagsimula at x equals to 9. Tapos ito as positive kasi pataas siya. Tapos yung slope nito is the same as 6 over 9 din. Kasi ito nga yun, no? Yung triangle na to. Okay, binaba lang natin para manegate siya. No? So yan. So this is m over 6, x minus 9 cube. Tapos, for the 77.4, so gagamitin natin is itong number 2. Okay? Point of application is A. Tapos this is an upwards loading. So this is the term that we want. So 77.4, which is P, x bracket x minus 9 raised to 1. Tapos ito yung tatandaan nyo, yung mga loading na nandun sa positive end, katulad na lamang ng 39.6, hindi siya isasama. Okay? So ano siya isama doon sa function. So that is our moment function. So that's m equals EI V double prime is equal to this. Tapos, according to the method, sabi, double integration, kailangan natin siya integrate twice to get v. But before that, I have to emphasize that you should be mindful of where the origin is. So, kunyari, from the left end, minove ko yung origin dito. Okay? Tapos, ito pa rin yung ating magiging extended load and yung load na in-apply natin to negate the excess of the extended load, no? Ito pa rin yung support reactions. Paano na natin gagamitin yung table kapag nandito yung origin? Hypothetical lang. So, doon sa load above, okay? So, gagamitin pa rin natin to. And then, the slope is still the same. It's still 6/9. Kaya lang mag-iba yung A. Yung A natin should be this coordinate here. Ano coordinate nito? Okay, the coordinate of this point is x equals -9. Bakit -9? Kasi nandito nga yung origin natin. So kapag ginamit mo yung table natin, you will get -6/9 divided by 6, x minus quantity -9 cube. Okay? So yung mga susunod na terms, you will notice a equals 0 for the triangular loading, A is equal to 0 for the 77.4, and ito, hindi pa rin ito isasama kasi nandoon siya sa positive end ng x. Okay? So be mindful of where the origin is. No? Next, be mindful of the positive x. Bakit? Kasi nga, sa table natin, yung positive x is to the right. No? Tapos, you may have wondered kung pwede ba yung ganito treatment, no? So, makikita nyo, you have a constant distributed loading doon sa taas, tapos you have a triangular loading doon sa baba, such that if I add the two, mag-result is yung original loading natin. Kaya lang, pwede mo bang gawin to? Okay, so isa-isay natin, check natin, no? So, for example, yun, no? This is our origin, and yung positive x natin is to the right. Yung constant distributed loading sa taas, wala tayong problem. Kasi nagsimula siya sa x equals 0, nag-end siya doon sa positive end. Tapos, yun no, magagamit natin yung table is what I'm saying. However, for this triangular loading, hindi natin pwedeng magamit yung table. Bakit? Kasi ang requirement ng table na to is as you go from the left end to the positive end, dapat linearly increasing yung loads. Itong load ba na to, is this linearly increasing as you go from left to right? No, it's actually linearly decreasing. Kaya hindi mo to pwedeng gamitin. Yan. So triangular load needs to be linearly increasing based on the sense of positive x. Okay? So I hope that's clear. So now, recall, this is our moment function. Okay, so nakikita nyo, hindi pa ako nag-simplify ng anything. Next is we need to integrate. So yung form na gagamitin na lang naman natin is x raised to, the integral of x is equal to x raised to n plus 1 over n plus 1, no? Yan. Yan. Integral of x dx is equal to x raised to n plus 1 over n plus 1 plus integration constant c. So ito yung gagamit natin form. And if you integrate once, you'll get ei times the slope. Okay, so that's ei v prime. And this is the first term. Okay, this is the second term. This is the third term. And don't forget the integration constant, c sub 1. So again, itong form lang naman yung ginagamit natin. Nothing difficult in this step. Next, integrate one more to get EIV. So that's what you want, yung V, which is the deflection. So if you integrate, you get this, you get this, you get this, you get C1x, and then you get another integration constant, C sub 2. So yung next na trabaho mo is solve yung C sub 1 and then C sub 2. Okay? So, how do we solve C sub 1 and C sub 2? Gagamit ka ng boundary conditions. So yung boundary conditions, kukuha ka na information doon sa support. So you know that at the roller support, that is at x is equal to 9, wala ka dapat deflection. So if you plug in x is equal to 9, okay, 9 here, 9 here, 9 here, 9 here, tapos equate mo to sa 0, what you'll get is this equation here. And as you can see, this is one equation with two unknowns, C1 and C2. So ibig sabihin, kailangan pa natin ng isang boundary condition. Kukunin natin yon doon sa isa pang support. at x equals 24 naman, it's still v is equal to 0. So if you plug in 24 here, 24 here, 24 here, 24 here, and equate it to 0, you'll get this. So you can see here two equations, two unknowns. This is a system of equations. If you solve for C1 and C2 using your calculator function to solve the system of equations, you'll get C1 is negative 256.5 and this is C sub 2, 2636.55. Okay, tapos ipa-plug in na natin to pabalik and then we solve for V. So yung form natin is V is equal to 1 over EI. Okay, so yung EI nilipat ko na sa kabila, ha? Kasi V yung hinahanap nating equation. V equals 1 over EI times this quantity here. Okay, V equals 1 over EI times this big polynomial here. Okay, so as you can see, no, very minimal lang ako mag-simplify. Kasi hindi naman kailangan. So we know that this equation describes how the beam deflects. And this equation is unique for this origin and for this positive x. Okay, pumalinaw yan. Yan. So pwede na natin makuha yung deflection at the free end. And saan ba yung free end? So ito yung origin, di ba? Which is also our free end. So what we want is yung v at x equals 0. So if we plug in, so x equals 0. So plug in ako ng 0 dito. So you have 0 minus 0. So 0 yung term na to. Okay. And then I plug in 0 here. So the term is negative. So dapat wala rin tong term na to. Remember, kapag negative yung nandun sa bracket, 0 lang yung buong term. So ito rin, no? 0 minus 9, you have a negative 9. So wala rin to. So you have negative 256.5 times 0. So wala rin to. So ang natira sa is 263.55 na positive. So it's V is equal to 1 over EI times 2636.5 positive. Ibig sabihin, pataas. Contrary to our initial assumption, so showing the deflection curve again, or elastic curve, initially, na-show natin na bababa yung free end, yan, bababa. Yun, nalaman natin na tataas pala siya. So perhaps this is our revised deflection curve. Okay? Now, pwede na tayo mag-compute ng max deflection. So yung max deflection, i-check nyo yan sa location ng zero slopes and kapag yung problem natin as a cantilever and overhang, i-check mo palagi yung free end. Sa problem natin, alam na natin yung deflection na to. So ang i-check na lang natin is yung mga zero slope. Okay? So that's a math theory, no? Kapag nag-zero yung slope sa isang curve, ibig sabihin nagma-maximum yung value ng curve na yun doon. So yan, hanapin natin yung location ng mga zero slope gamit yung slope equation. Yan. So this is our slope equation. No? Nakikita nyo, this is our C sub 1. Pinlagin ko na yung C sub 1. Tapos, yun, equate na lang natin to sa 0. Okay? So yun, check the deflections where there is zero slope. But remember, you are dealing with Macaulay Functions. So do not just solve, no? Ang gagawin mo dito is, i-consider mo yung different domains. Ibig sabihin, ganito, no? You will shift solve by segments. What do you mean by segment? So, kunyari, sa beam natin, meron tayong dalawang segment. This segment and this segment. Okay? So, yun ay sa pinagigitnaan ng mga applied loads. Yun yung mga segments na i-consider nyo. And bakit ganun? Kasi, yun nga, yung mga terms natin, kapag negative, dapat dinadrop mo siya. For example, if I consider this segment, 0 to 9, x element of closed 0 to 9 open. So, ibig sabihin, hindi included yung 9, no? So, it's just a math term. No? Titignan nyo yung function natin. So, kapag 0 to 9, i-retain natin to kasi hindi magne-negative yung nasa loob. Kaya lang, pagdating sa second term and sa third term, palaging negative yung nandun sa domain. Kaya i-drop mo to. Okay? So, pag considering the domain, kapag palaging negative yung term, tatanggalin mo dapat siya. Okay? So, in other words, our equation reduces to this. 0 equals negative 1 over 4 times 9 or 1 over 36 times x minus 0 raised to 4. May notice na dinrop ko na yung angular brackets, pinalitan ko na siya ng regular na parenthesis. Kasi alam ko naman na palaging non-negative yung nasa loob nito, no? Okay? Tapos, again, wala na tong dalawa. Ang meron na lang is yung constant. Huwag niyo siya kinakalimutan. And then, pwede na kayo mag-shift solve. So, pag shift solve mo to, ang makukuha mo is wala kang real na root ng x. Okay? So, ano yung implication nun? Ibig sabihin, from 0 to 9, wala kang zero slope. Okay? Tapos, pag na-determine mo yun, pwede mo na ulit i-revise ng elastic curve. So, previously, this is what our elastic curve looks like. No? And nalaman natin, wala ka dapat zero slope dito sa 0 to 9. So, perhaps, ganito yung itsura ng elastic curve. Okay? So, ano yung implication? Yung implication is that, yan, wala kang zero slope, wala kang zero slope from 0 to 9. Tapos, we can deduce from this analysis that there's only one location of zero slope. And that is somewhere here, siguro, no? Yan, somewhere there. Okay, so expect natin yung location ng zero slope is between 9 to 15. Tapos, yun, somewhere here. Kung anong x man yan, no? Perhaps x equals 15 or something. Okay, so ganon. Now, we check the next segment. So we're done with this segment. Now we check with this segment here. So that's 9 to 15, no? Mag-ihat kasi hindi dapat 15 yung dulong term. Dapat 24. Yan. 9 to 24. Kasi ito yung origin. So this is x equals 9. This is x equals 24. So from 9 to 24, titignan mo kung ano yung mga terms na mawawala or mariretain. So this term is retained kasi palaging non-negative yung nasa argument, yung nasa bracket. So ganun na, dinadrop ko kapag negative siya doon sa domain. Okay? So ganun lang. So for example, dito naman, from 9 to 24 na x, hindi rin magne-negative yung ating bracket. So i-retain ko to. So ito, hindi rin ito magne-negative. So this is retained and this is the constant. So, ibig sabihin, lahat ng terms nandun sa equation natin. No? Yan. Okay? And that's still equal to 0. Tapos, ito na, no? So, you have a fourth root polynomial, a 4-degree polynomial. Tapos, pwede ka nang mag-shift solve. Kaya lang, you need to shift solve with the value according to the analysis nung sa elastic curve. And we said earlier that the curve can look like this. Okay, so we want an initial value of around this much, no? Okay, so yung kasi depending on the initial guess of the shift solve, nag-iiba-iba yung root ng polynomial na makukuha nyo. Okay, so ganon, no? So let's say you do 15. So if you do x equals 15 as the initial guess doon sa shift solve niya sa calculator, then what you'll get is x equals 16.89. Pag nakuha mo yung 16.89, so perhaps this is 16.89, we're quite sure that this is the location of the zero slope. Kasi based on our analysis, isa lang naman yan, no? Isa lang naman yung makukuha mong location ng zero slope. So if we plug in 16.89 to this equation here, so this is 16.89, this is 16.89, this is 16.89, this is 16.89, what you'll get is a negative 2.2825.96. That means that at 16.89, bumaba yung beam natin. Okay? So that's a good sign na negative yung nakuha natin kasi na-expect nga natin based on the elastic curve na bababa yung deflection. Okay? In between the supports. Okay, kaya kami downwards here. And if we compare this value to the v at x equals 0, then this is greater, and therefore, yan yung ating max deflection. And that ends our discussion. Thank you for listening.